difference of terms, 2 or more, you cannot touch it. This is it. It's carved in stone. Unless you can add them or subtract them. But if they're not given to you, you cannot touch this. So the product can be broken up. The ratio can be broken up, assuming these conditions are fulfilled. But the sum of the difference, never. So what I mean, if you have the square root of 9 plus 16 is the square root of 25, which is 5, yes. But if you have the square root of x plus 1, this is carved in stone. You can't touch it.
This is a factor.
Because they are terms.
Right.
Because they are not factors. Yes. Because they are terms. Remember, we cannot do anything with terms. We cannot simplify them. We cannot, nothing.
When if it asks you, it would just equal x plus 1. Or would it still just equal the square root of x plus 1?
This is it. It's carved in stone. Don't touch it. You cannot touch this. It's done. It is what it is. No one can change this into anything else. The square root of x plus 1 is carved in stone. But if you tell me x is 8, oh, then I'll say the square root of 8 plus 1 is 9, so the answer will be 3. But if you don't give me any value, this is the simplified form. No one can touch it.
And could you give the examples for the other two rules, the a times b and the a divided by b?
Yeah, this is the one right here. So the square root of 1 over 4 is the square root of 1 over the square root of 4, which is 1 over 2. Exactly, this one. That's why I mentioned the product and the ratio. Exactly. So you can separate it. If it's a product or a ratio, meaning products and factors, we can deal with those. Okay, here's a situation. I mentioned last time, and I'll mention it again right here. If the index is even, this quantity can be only positive or 0. Positive or 0. Look what I have now. I will have to write this is not real, meaning it's imaginary, meaning it does not exist. I have no real number. I have no real number that I squared to get negative 100. That's what the question is all about. Do I have a real number that I squared to get 1/4? Yes, it's 1/2. I can square 1/2 to get 1/4. Do I have a real number that I squared to get negative 100? No. There is no such thing. I don't have a real number that I squared to get negative 100 because everything I square will be positive. I can never get negative 100. So I have to write that the answer is not real, meaning not a real number.
I did have a question.
Yes.
When you try to rationalize a denominator, radicand in the denominator, like for this example, negative 100.
But this is not, we're not rationalizing because it's not a denominator, it's not a fraction.
Right. But hypothetically, if it was.
So if you're talking about 1 over the square root of 2, you have to multiply by the square root of 2 and divide by the square root of 2 to rationalize the denominator.
But if it's negative, like the negative 100.
It's not real. We cannot apply the rules. Yes, we cannot.
If that negative was outside the
so
radicand.
Yes. So we cannot apply, that's why I put this here. So if these numbers are negative, which is not possible, we cannot apply these rules. These rules are applicable only when we look at real numbers.
Okay.
If they are imaginary, we cannot apply. These rules are not applicable to imaginary. Good, we're gonna get to this later, so let me just finish it here, and this product is 2, since Glenn asked about it. Okay. Yes, Sarah, go ahead.
Piggybacking off of Glenn, if we had negative square root and then 100, that would be negative 10?
Yes, yes, right here. Negative, the square root of 100. The square root of 100 is 10, with minus in front is negative 10.
So you would just carry the negative sign at that point.
I'm applying the order of operations. I have to apply the power first and then multiply.
So all numbers that are negative that are being squared are imaginary?
No. No. If you give me anything that you want me to square, I get a positive number.
Oh no, I meant like the square root of a negative number.
Yes,
for all.
the square root of a negative number is always imaginary. Not the cube root. So if I have the cube root of negative 8, that exists and I have an answer. And the answer is negative 2. Why? Because negative 2 raised to the third power is negative 8. So odd indices are friendly. The even index is the issue.
So if it's an even index, then if it's squared to a power of negative, or a negative squared power, it's imaginary. But if it's a odd index, then it's valid.
Exactly.
Okay.
Because I can find a number that I cube to get this. But there is no number that I can square to get negative 100.
Okay, that makes sense.
But I can cube negative 2 to get negative 8. But there is no number that I square to get negative 100. So that's why this is not real. Very good. So here we say, so this is 1.3, okay. Determine whether the square root of 25 is rational. Irrational is not a real number. Well, the square root of 25 is 5, so it's a rational number. It's not irrational. Irrational, remember, it means pi e 1.392453978 la la la. It continues forever, no pattern, and it is a real number. So that is a rational.
So the irrational numbers would be something that you can't even, like square root of 11. You can't.
Exactly. Square root of 11 is an irrational number, correct?
Okay, that makes sense.
So here you're just going to type in 5 and move on. Good. About the square root of 1/9. This is just one of the properties that we just discussed. What will you write for the square root of 1/9? Rational, not real, or irrational?
Irrational.
1/9 is 1/3. So 1/3 is a rational number. So let's clarify this. Anything in the fraction form, rational ratio. 1/3 is rational. 5 is rational because it's over 1. 1/7. What is irrational is something that cannot be changed into a fraction with no approximation, like pi and e, the square root of 3, the square root of 7, the square root of 5, and so on and so forth. These cannot be changed into a fraction. They cannot be changed into a ratio. I have to truncate them somewhere to change them into something, but I cannot completely change them into a ratio without approximating them. So this is irrational because it's 1/3.
So irrational numbers are not able to be perfect squares, which is why they're irrational?
That's a very good question, but they are perfect. I mean, they're not perfect squares in the sense that the square root of them is not an integer.
It would be like a run-on.
Yes,
That's
yes,
Okay.
yes.
okay.
That's a good explanation. So if I cannot take the square root or the cube root, so for example, the cube root of 9 is irrational. It will go on forever because I don't have an integer that I cube to get 9. So remember we discussed last time that the cube root is power 1/3. You have other options, but I prefer the power 1/3. So 9 and the power 1/3. And you will see it will go on forever. It will be a total gibberish. And there is no pattern. And no one can change this. If you try to change this into a fraction, it's not going to do it because it can't.
Could you give an estimation?
Yes, you can approximate it, but that doesn't mean that you are changing this number into a rational number.
Right.
It's still, it was born irrational, it will die irrational, so to speak. No one can promote it to rational. It will be irrational all its life.
Perfect.
Good. Well, let's see what it wants here. Select the correct choice. Okay, so they want us to put the 1/3 in here. 1 divided by 3. Fine. Good. Is the square root of 48 rationally rational or not a real number? And that's exactly what Sarah just asked. There is nothing that I can square to get 48. So it is irrational. It's not rational because you will never be able to change this number into a ratio, into a fraction. Not possible because it's 16 times 3. So let me discuss this. It's a very good example. So we can simplify only if I change it into a product of a perfect square and a non-perfect square. And then I'm using the property we just discussed. And then I can take the square root of 16. But this piece still makes the whole thing irrational. Because there is no number that I can square to get 3. So therefore, because the square root of 48 is not, I don't have a number that I square to get 48. It is an irrational number.
I like the way you broke that down. That made a lot more sense.
Because now we have the property. The property is very important. So if you remember when we were given, I don't know, x squared minus 1 to completely factor, the same thing here. When we are given something like this, we will be asked to completely simplify. And we will have to write the square root of 48 equals 4 the square root of 3. Meaning, I can no longer simplify it. Oh, I'm sorry, you couldn't see anything. I'm so sorry. Okay, so remember when we were given x squared minus 1 to use the difference of squares to completely factor. When we are given something like this, we're asked to completely simplify till it cannot be further simplified. So 48 is 16 times 3. 16, the square root of 16. 16 is a perfect square. That's why the square root of 16 is 4. But the square root of 3 stays as the square root of 3. So therefore, we cannot do anything else. So this is the simplified form of the square root of 48. And this is it.
Would that kind of be called the factor 48?
You can call it a factor here, because that's what I did. And then I fully simplified it. Yes. So to speak, yeah. They are, radicals are tedious. They're not fun, and they are cumbersome to work with. So, Type an integer or decimal round. Okay, let me see what. Select the correct choice below and fill in any. Okay, the square is not. Type an integer or decimal rounded to 2. Oh, that's not what they want. Fine. Okay. Type an integer, which is not possible, or a decimal rounded to 2 decimal places. Fine. So in this case, we just simply take the square root of 48 and we round it up. 6.93. But this is not what we want later on, but the simplified form as I showed you. Yes, this is also rational or irrational?
Irrational.
Yes, it is irrational. And the simplified form is not a decimal rounded to 2 decimal places, but
I could do the square root of it though.
exactly.
Like
Yes, how would you
5.
break it up?
5 to square root of 2.
Exactly. This is the value. 25 times 2. So this is 5, the square root of 2. This is the simplified form. Exactly. You got it. Good.
Almost like taking the smallest prime number out, and then if that's factor, that's
No, the largest perfect square out.
okay.
Okay. What would you say about the square root of negative 81?
Irrational. Oh no, it's not squared. But it's not real, right?
Yes.
It's negative.
It's not a real number.
Okay.
A brain process that.
The square root is not a real number. Good. Now, very important, the square root of 6.8, everything squared.
Wouldn't that just be 6.8?
Exactly.
The absolute value of it?
No, because it's a number. It's not x. Very good. Very good point. Very good point. Very good point.
So if it's a number, you don't do the absolute value.
No, because it's already 6.8. There is no need for absolute value on 6.8.
There's no variable.
Exactly. So let me explain this. The nth root of a to the mth power. My n has 2 bubbles, my m has 3 bubbles. This is a raised to a ratio. It's another way of writing a radical. If you remember, we had a to negative n, another way of writing 1 over a to the nth power. The same thing here. The nth root of a to the mth power is, copy the base, and the power is a fraction. This goes to the numerator, and the index always goes to the denominator. So, what is the main importance of this? To remember that any radical can be expressed as an exponent. Any radical is equivalent to an expression with a rational exponent, an exponent that is a ratio, with an expression with an exponent that is a ratio. Very super important. So here's what I'm telling you. If I see an expression with a power that is a fraction, I know it's a radical. If I see a radical, I know it can be converted into an exponential notation with a power that is a fraction. And you can say, what are you talking about? What is this? How are these connected? Here is the way they are connected. And why the answer is what it is. Is because the square root of 6.8 is 6.8 raised to 1/2. Where does this come from? The power is 1. The index is 2. power is 1, index is 2. So now when I square this, I basically have 6.8 to 1/2 everything squared. And I know the exponential rules. I copy the base, and what happens to the exponents?